Hello, in this episode I'm going to explain how to evaluate 3D point components. On this excavator are reference points applied on the major parts. These parts are considered to be rigid. Therefore, the groups of reference points on the parts represent the behavior of the parts throughout the digging process. The goal in this episode is to determine the 3D positions of these points in each individual stage and therefore to analyze the motion of the excavator. In order to explain this to you, I'm going to focus on the undercarriage and the superstructure of the excavator. Again, components are the base for the inspection, but this time you have to use a point component. You can combine measured reference points to a point component. Each point gets an own ID which is identical in all stages. Please find more detailed information about point components in the direct help. As soon as you open the point component dialog, the measured points become visible. First, select the points on the superstructure with Ctrl and the left mouse button, or with Ctrl and the left mouse button and dragging. Create now also the point component for the undercarriage. The software traces the point component in 3D space in every stage. You can use a 3-to-1 alignment again to transform the point component into a reasonable coordinate system. Click 3 points for a plane, 2 points for a line, and 1 point for the origin. You can now use the displacement check to analyze the movements of the point components. The software creates a vector field. The vectors show you now the direction and size of the movements in 3D space. However, in most cases, you might be more interested in the movements between components. You can see in this video that the superstructure is moving downwards when the bucket hits the ground. So a typical question would be, how much does the superstructure move down relative to the undercarriage? You can create a displacement check in Z direction only, as other directions are irrelevant for this question. You can place deviation labels also on vector fields. In the previous episode, I have explained how to create stage ranges. As you are now interested in the vertical movement only, you can create a stage range for this area on the timeline. The scaling option, all visible stages of the legend, now scales the legend also only for the stage range. If you look closer now, you can see movements not only on the superstructure, but also on the undercarriage. This means that both components move in 3D space. The movements you can observe on the superstructure are not entirely the movement relative to the undercarriage. The question is, how can you solve this problem? You can use a rigid body motion compensation. Go to the Create Alignment menu and select Transform by Component. Select the component undercarriage. You can see now that the vectors on the superstructure have become much smaller and the vectors on the undercarriage have nearly disappeared. A rigid body motion compensation corrects the absolute movements in the 3D space by the relative movement to another component. Let me explain this with this animation. You can see various parts which are moving in 3D space. Now, the parts which appear in red are used for the motion compensation, which means they will be held in place. The movements of all other components are compensated towards the red component. You can find the rigid body motion compensation now in this menu. You can switch it on and off at any point, but you can only have one rigid body motion compensation active. You can also inspect construction elements in addition to the vector fields. For example, the angle between boom and arm. In order to inspect an element, you have to construct it first. First, create point components for the boom and arm. Create now two lines over Construct, Line, two-point line. Click 2 points with Ctrl and the left mouse button to create the line. Create now an angle over Construct, Angle, two-direction angle. Select the two lines with Ctrl and the left mouse button in the 3D view. Invert the directions to get the inner angle. You can also use iInspect in the software to perform checks. iInspect is a pie menu that offers the appropriate functions for a selected element, like in this case the angle. Again, you can also view the angle in a diagram. In the next episode, I'm going to show you more about reporting.